What's up, Mathnasium Gym Rats? Welcome back to another video. We're going to be expanding on what we learned with graphing linear equations with this video, where we're going to learn a couple other ways that you can graph linear equations that are not in slope-intercept form. So really quickly, for those that don't remember, let's do a review of what slope-intercept form is. Remember, it has to look like y equals some number times x plus or minus some constant. So really, slope-intercept form always has this y equals. So let's do one like maybe y equals 5 thirds x minus 1. So the steps that I gave you last time for graphing a line like this is identify the slope and the y-intercept. Our slope here is 5 thirds. Our y-intercept is -1, so we're going to go down. On the y-axis, plot our initial point, our y-intercept. That's our starting point, and we're going to use this pattern of 5 thirds. Okay, remember that's rise over run, so my rise is 5. So if I go up 1, 2, 3, 4, 5 from that point, it says that my run is 3. Now my slope is positive, so if I go to the left, I could go to the left or to the right here. It says slope is positive, so I'm going to go 3 to the right, which is actually right there, and then up 1, 2, 3, 4, 5 over 3. Great. And if I go down 1, 2, 3, 4, 5, I'm going to go back 3 to keep everything in line. Then I'll get out a straight edge. Make sure my line is straight. Remember, there are an infinite number of points on this line that keep this equation true. But that's what you learned before. If you have something that looks like this in slope-intercept form, it's so convenient because you can see the slope, you can see the y-intercept, and you don't even really have to write them down once you get the hang of it. You just look, you know where to start, and you graph. It can go really, really fast. The problem is sometimes you're dished lines that look like this. So the second method that I'm going to teach you, the first method that I'm going to teach you, when it's not in this form, is to force it to be in slope-intercept form. So you take the form that it's currently in, and then you shift stuff around using the inverse operations we learned in Unit 1 to force it to be in a form that we understand. Now, when you look at these numbers, there's a way to detect that these numbers kind of have meaning, but not directly to the graph. So like slope-intercept's so nice because of the slope and the intercept have meaning on the graph, right? So we're going to try and get the line to be, or the equation to be in that form. And what we can do is we can use those inverse operations. So we want to try and get y by itself. So the first step here is to subtract 2x from both sides. So you're probably saying, well, these aren't like terms, so you can't subtract them. That's correct. These are. We're just moving that positive 2x to the other side by using inverse operations, and you're left with minus 3y equals, and then you can say negative 2x plus 12. Now to get y by itself, I'm going to divide both sides of the equation by -3. Now remember, it's both sides of the equation, so you have to divide everything on the other side by -3 as well. -3 divided by -3 is 1, so you have y equals -2 over -3 is actually, negative divided by a negative is a positive 2 thirds, and positive 12 divided by a -3 is -4. So there we go. 2 thirds x minus 4. Now this is in slope-intercept form. So we can see the slope, we can see the y-intercept, and we can go ahead and plot our points. All right, 2 thirds. I'm going to go rises 2 up 2 over 3. Make sure my line has a positive slope. 2 over 3 up 2 over 3. If I go down 2, I'm going to go back 3, and then we have our line in all of its glory. That's method 1. You just use inverse operations to make the equation say y equals. And once we are done, it can go very quickly. Common mistakes on this problem that I would expect to see from students would be to forget this minus sign when they carry on to the next step. Another one might be to try and subtract these, but we can't because they're not like terms. So we just keep them separate. We just basically move that to the other side. And then the other mistake, common mistake here would be to divide one of these things but not the other. So just be careful. And then, of course, mixing up minus signs down here. All right, let's see the next one. All right, you can pause the video and try and graph this one on your own if you'd like. I'm going to just start right now, though. Here we go. All right, so first thing we do, I want to get y by itself, so I'm going to add 2 to both sides. And you end up with negative x plus 2 equals 4y. I'm now going to divide both sides by 4 to get y by itself, and then end up with 4 divided by 4 is 1, so we just have y over here. Here, the coefficient out in front, negative x, the coefficient there is 1. So this will be negative 1 over 4. Negative divided by a positive is a negative. And then 2 divided by 4 is plus 1/2. All right, I'm going to rewrite this equation with y on the left. So basically, it's y equals negative 1 over 4x plus 1/2. So this one's a little strange because we're not on a grid mark. Our y-intercept is 1/2 here, and our slope is negative 1 over 4. So when I go up 1, to keep my slope negative, I'm actually going to go to the left 4. When I go up 1, I'm going to go to the left 4. When I go down 1, I'm going to go to the right 4. Now, none of these points are falling directly on the intersections of my grid line, but that is just fine. All right, I'm going to run through there. And there's our line in all its glory. Now, you couldn't really see that from this equation, so we forced slope-intercept form. All right, let's take a look at method 2. Method 2 is a really quick way to graph something that's not in slope-intercept form a lot of the time. And what you do is you just pick an x value or a y value, it doesn't matter, and then you plug that value into the equation, and then it will spit out the value associated with the value that you plugged in. Basically, we ask the equation a question and it gives us an answer, and then we plot the point. Okay, we put in half a point, it gives us the other half of the point. So remember, an equation describes a set of points. So it's kind of like the key to a puzzle. Okay, the puzzle is where the line is, describes where the line is. And so we just have to ask it a question. So here's how we do it. We just pick an x value. So we could say, like, let's pick x equals, I'm going to pick something easy that I like to do math with. Something that would be easy to do at math with would be x equals 0. The reason I chose 0 is because 0 times anything is 0, and 0 plus anything is that thing. So if we plug this in, we're substituting for x here. We're taking this value 0 and we're plugging it in for x, so the x kind of goes away. So we're asking a question here. If I plug in 0, what is the y value of the line at x equals 0? Okay, 2 times 0 is 0, so that just goes away. Okay, and then we want to divide both sides by negative 3 here to get y equals negative 4. So what this is, I'm going to kind of spread this out here. What we just did is we picked a point, x equals 0, okay? And let me I'm going to formulate our point here. So we have a point, something, comma, something. We picked x equals 0. And the answer that we were given back was y equals negative 4. So you have to make sure, when we plug in a point, we're making sure that, whichever one has an x goes first, whichever one has a y goes second. So 0 comma negative 4 is something that is on our graph. And if you look back at the first example, this is the same equation. So a little trick someone showed me, if you pick 0, basically it's just eliminating that term. So what you can do is kind of just picture the equation without the x term if you're plugging it in for 0. And this is called our, well, if you plug in x equals 0, that is our y-intercept. Y-intercept is always where x equals 0, and you can see that in y equals mx plus b. If you plug in a 0 for x, you always get your y-intercept b. Doesn't matter what the equation is. Whoops, let's see here, delete. All right, cool. Let's get back to the pen tool. And now I'm gonna pick y equals 0. This is our x-intercept. Pick the x-intercept. Let's do some math here. This time we're substituting for y. Okay, so for y, so we leave the x, 2 times x minus 3 times y, which is 0, equals 12. Okay, negative 3 times 0 is just 0, so you get 2x equals 12. What number times 2 is 12? That number is 6. So here, remember, I put this number in the first slot, but that's because it was x. X is actually the 6 here. So this is 6, comma 0. All right, so let's go here. 6, comma 0. You go over 6, you go up 0. So our line travels through that point as well. Well, we can check. Let's go back. Is that what actually happened? Yep, that's the same line. We can see that here. But you don't have to pick. X and y equals 0. You can pick any number that you would like. So I'm going to pick a couple more just so you can see. And I want to pick one that's not going to give us a nice and pretty answer. How about negative 5? I'm going to do this just for fun. Let's pick negative 5. X equals negative 5. So x equals negative 5. Let's see here. If I had to guess, where is the y value going to be? If I trace this down, it looks like it's going to be somewhere in here, because you can see the line is going like that. So if I pick negative 5, it's going to be somewhere around probably negative 6 for an answer. So let's plug this in. 2 times negative 5. I'm going to make the screen a little bigger so it's easier to see. Minus 3y equals 12. 2 times negative 5 minus 3y equals 12. We're solving this equation. 2 times negative 5 is negative 10 minus 3y equals 12. I'm going to add 10 to both sides, which will give us minus 3y equals 22. Oh, interesting. Okay, so we divide both sides by negative 3, and you end up with negative 22 over 3. As a mixed number, that is negative 7 1/3. Okay, interesting. So this is the point. What we just found is the point x equals negative 5. At negative 5, we're down at negative 7 1/3. So let's go negative 5. I'm going down to negative 7 1/3, which is maybe right about there. And you can see that those lines are clearly, or those points are clearly in a line and they're connected. So that's kind of reassuring. So let me offer you a little bit of strategy with this method. This method always works, which is why it's awesome. I mean, it works on basically, it doesn't have to be a line. It could be any kind of function or equation. What's really cool is it's kind of self-correcting. Now, what I mean by that is, what's the absolute minimum number of points you need to draw a line? Well, you only need 2, but if you mess up one of those points, then your line's going to be wrong. If you graph 3 points, or if you use this method to find 3 points on a line and all 3 of them are in a line, that's very reassuring to you that you've done your math correctly. If you graph 3 points and like one's here, one's up here, and one's over here, and none of them are in a perfect line, do another one. Do a 4th or a 5th or a 6th until you can really see the pattern emerging. And once you know the pattern, if you know it's a linear equation, once you know the pattern for the slope, you can repeat that pattern. The pattern here is up 4 over 6. So the slope of my line then, we've just discovered is 4/6, which really simplifies to 2/3. Then you can go through and manually put in the remainder of the points based on the points that you already had. That's kind of exciting. All right, let's go back to purple. Cool. Well, that's the same line that we already did. So what you can do here, like for method 1 is, if you're just reading a graph, like where is my line going to be at -8? Well, we go down, it's like -9 and a bit, and you can see that right on the graph. Perfect. Let's do another one. You try this one on your own, give it a shot, and let me know what you get. I'm going to start in just a minute. I recommend picking numbers that are easy to do math with. Turns out 0 is a good option. All right, so pause it if you are going to work on it. Here we go. Let's pick x equals 0. For x equals 0, then this equation looks like 5y minus 4 equals -2 times 0, which is 0. So you get 5y minus 4 equals 0, and 5y equals 4. If we add 4 to both sides, y equals 4 over 5. Okay, so we just got the point 0, comma, for our y-intercept. We got the point 0, comma, 4/5. 0, comma, 4/5 is really close to 1. Okay, let's plug in y equals 0 this time. For y equals 0, we get 5 times 0 minus 4 equals -2x. 5 times 0 is 0, so we get -4 equals -2x. Divide both sides by -2, and you'll get x equals 2. Did I do that correct? Let's see here. Oh yeah, I don't know if I graphed this one in class. Interesting. So this is the point 2, comma 0. So the slope of my line is not necessarily super clear here. So I didn't land on a grid line here. So what I might want to do is pick a number for my third point to check to see if I'm doing math correctly. Maybe pick something that's way to the left or way to the right, so you know that our line is going to be accurate when we sketch it. If I try and connect these two with a ruler, there's a chance, like I can draw a bunch of lines that look like they're going through these 2 points, but they're not super accurate, right? And so I could probably even bend it even more, probably put one up like this. If you're really sloppy, you can kind of make something like that. So the lines are not going to look very good unless you get them really spread out. Then your actual line is going to be a little more accurate. So why don't we come way down to the left here, or rather, yeah, let's go way down to the left and let's choose like maybe -10 and see what happens. X equals -10. So I'm going to come down here. Where's my line? It's probably going to be up around here, around 5 or something. So let's try it. 5y minus 4 equals -2. I'm going to be working right into my own math here. So I'm going to actually move this up a ways, like so. -2 times -10. So that turns to be 5y minus 4 is equal to 20, and 5y equals 24 if you add 4 to both sides. So y is equal to 24 over 5. What is that as a mixed number? Well, we think about that as 4/5. So it's right about 5. I was pretty close. So that's my third point. I've got 3 points. They look like they're in a line. That's convincing enough for me to draw a line through these points, through the middle. I don't know how good that line is, but I bet it's pretty close. Now, if I wanted to make it more accurate, I could plug in 10 as well. All right, this is fun. I'm having a good time. All right, so let's talk about what the benefits of each method. So the benefit of method 1 is it's going to be a lot faster most of the time. The benefit of method 2 is that it always works, and it really is just kind of a fail-safe. It's a good way to check your work. It's kind of got a self-correcting system. If you screw up some math in method 1, your whole line's going to be wrong. Like if you make one mistake. However, if you make a mistake with method 2, you could always do a couple more points to convince yourself and make sure that your line is correct. All right, so right here, which method do you think is going to be easier? My vote, we'll switch colors for this one. My vote is method 2, and here's why. I can pick clever values for x here to get rid of the fraction. So notice if I wanted to put this in slope-intercept form, which you can, you could just divide both sides by 4 or multiply both sides by 1/4. That's actually pretty quick if you're comfortable with fractions, if you want to do that. Method 1 is just fine here. Method 2 is also pretty simple, and I'm going to show you why. All right, you can just pick x equals 0, plug in 0 for x, 1/3 times 0, well that's easy, plus 2 equals 4y. For me, I would probably choose method 1, but if you struggle with fractions, maybe method 2 is your best bet if you're creative in the numbers that you plug in here. So 1/3 times 0, so you end up with 2 equals 4y, and y equals 1/2. So 0, 1/2 is on our line. Super. All right, well, we need some more points. So what would be another great number to plug in for x that would be really easy to substitute for x and multiply by 1/3? Well, why don't we just pick something that we know is divisible by 3. 6 is divisible by 3, so multiplying by 1/3 is going to be very easy. 1/3 of 6 is just 2. So let's plug that in. So you'll get 1/3 times 6 plus 2 equals 4y. 2 plus 2 equals 4y. 4 equals 4y, so y equals 1. So the point 6, 1 is also on my line. Now this has a positive slope, but it's very gradual. So you could do the same thing here and say, look, you can repeat the pattern. I went up 1/2 and over 6. Okay, so that means if I go up a whole, I'll go over 12, but that's off my graph. If I go down 1/2, I should go back 6. So now that we have our pattern established, we have enough information to kind of plot our line. Let's pick something. Let's pick something where we're going to get kind of a weird fractional answer. Actually, you guys have seen that already. I'm going to do this with method 1 as well, really fast. So with method 1 here, I would divide both sides. So this is method 1 in blue. I would divide by 4 and then divide by 4 on this side. 1/3 divided by 4, skip, change, flip, is equal to 1/3 times 1/4, which is 1/12. Okay, so this turns out to be y equals 1/12 x, and 2/4 is plus 1/2. Well, that's what we kind of already discovered, right? So if you like working with fractions, then you have your slope there, or you have your y-intercept and you have your slope. So you could start here and go up 1 over 12. Oh wait, that's off our graph. Plugging in points might be the way to go. Quick evaluation of the two methods. And just for kicks and giggles, let's plug in x equals 3. If you plug in x equals 3 here, you'll get 1/3 of 3 is 1, so you'll get 1 plus 2 equals 4y. 3 equals 4y, so y equals 3/4. So that's the point 3, 2 3/4. And those look like they're all in line. And we are all hunky-dory. I think that means happy. I'm not sure. Okay, there's my line in all its glory. Pretty fun. All right, let's take a look at this one. Which method do you think is easier here? Well, I don't know. Let's try putting it in slope-intercept form and see what we think. All right, in slope-intercept form, let's give it a shot. Well, I've got like terms on opposite sides of the equation. I got y separated, so I'm going to add 2y to both sides. And you'll end up with 3x plus 1 is equal to 3y minus 3x minus 8. All right, great. X's on opposite sides. Let's add those together, or use inverse operations, I should say. 6x plus 1 equals 3y minus 8. Okay, now the only thing that's on both sides, the only like terms that are separated here are the constants. And so I want to get it into slope-intercept, so I'm actually going to add 8 to both sides. And you'll get 6x plus 9 equals 3y. Now, why is this handy-dandy here? This is nice because all of the constants and the coefficients are all divisible by 3. So that when I come through and divide the left side by 3, left side and the right side by 3, we're going to end up with a very pretty equation that looks like 6 divided by 3 is 2x plus 9, plus 3 is equal to 1y. And I have my y-intercept and my slope. Y-intercept is 3, slope is 2, and slope is, m is a fraction, there would be 2 over 1. So I'd go up 2 over 1, keep my slope positive, all the way across my graph. Isn't that marvelous? You could go down 4 over 2 if you want to save yourself some time. Great. That's all I've got for this video. Hopefully you guys learned some other ways to graph lines that aren't just in slope-intercept form. So, well, I guess we learned one other way to graph lines is by plugging in points, but you now know how to graph really any form of a linear equation. You can plug in points, or you can solve that equation for y to find the slope and the y-intercept. Thanks for watching. I hope this was helpful, and we'll see you again soon with another video.